Picking up here anew with lesson number 9. Now we looked at an overall evaluation of network level security, endpoint level security. Part of what we do is, as far as evaluating our security environment, is to look and see if we have the proper controls set up at the network and if they are indeed configured properly. Now, the network systems, the network security systems that are designed for those purposes, we've talked about most of them already. We've talked about your firewalls, your next generation firewalls. We've talked about your intrusion detection, intrusion prevention systems. We talked about the data loss prevention systems, antivirus, anti-malware systems. All of those are devices and systems that are designed to provide us some level of security, mainly at the network layer. Now, I mentioned earlier as well, while those appliances are typically deployed at the network perimeter, well, I want those to also be rubber stamped and to be incorporated on each individual endpoint as well. That certainly contributes to that never trust, always verify concept as far as securing the network as a whole. Now, I mentioned to you earlier the process and the reasoning behind establishing baselines for all of our systems. The baselines are associated with individual assets that we configure and set up in our network environment. And those baselines give us a starting place, as it were, so that we can then have our other security mechanisms, again, the IDS, IPS, firewalls, antivirus, anti-malware systems, proxy services, data loss prevention systems. All of those will look to the baselines that are established on each individual critical asset. And that's the starting place. That's what they utilize to gauge what is normal activity or abnormal activity that should indeed trigger some type of an alarm or an alert. Okay. Now, you military cats are probably very familiar already with the Security Technical Implementation Guide. I'm going to give you guys a link now to the STIGS documentation. You can actually download the library directly from the one of the DoD websites, the cyber.mil website. Here is the link in that in your chat box. Okay. And also for the folks that are joining us on the audit spectrum there, I'm going to give you all my email address here. All the audit students, if you have an email, if something comes to you, the question that you would like to ask after you have left us in the session, please feel free to drop me an email. I always return my emails. Now, I get hundreds of emails every day, so it may not be within a couple of hours or may not be even the same day, but I promise you, if you send an email requiring a response, I'll guarantee you're going to get that response. Okay. So the STIGS documentation that I gave you, the Security Technical Implementation Guide, that is utilized not just in military Department of Defense installations, but that's a guiding document there that is used by lots of organizations on setting, on analyzing, selecting, purchasing, implementing, configuring, programming technologies that are designed to contribute to the strength of the overall security of any kind of enterprise. You will also find security guidelines and documentation from most of your reputable vendors of product. And when I say product, I'm talking about hardware and software and the combination of the two. The Center for Internet Security is another excellent resource where you can get guidelines, framework information, and orientated information, and information that we can use for setting and putting processes in place so that I can adhere to benchmarks. Benchmarks are metrics that we set along the way to first help determine where we are as far as the maturity level of our overall security environment, as well as where we wish to be. And then doing that gap analysis we spoke about yesterday gives us the ability to lessen that gap and go from where we are to where we wish to be from a maturity level in our security environment in general. So first, we have to baseline systems from a security perspective. We baseline it based upon preset standard configurations and then collecting information as we define what the acceptable baselines are, what the acceptable threshold of variance away from those baselines are before we start sounding alarms, throwing alerts up and so on. Now, here are a couple of configuration management, three different packages here, and these are just a smattering of the ones that are available out there. Puppet, Chef, and Ansible are systems that allow us to basically define and figure out if indeed our configuration of our systems, hardware, software, and network actually follows industry accepted rules and regulations for a secure environment in general. It also gives some good information on how specific type of companies may set up the base level security and baselining those systems so that they might meet some type of audit later on down the line if indeed they are held accountable for some type of compliance configurations. I have used the first two up there, Puppet and Chef. Both of those packages are very, very good, especially as far as measuring compliance on different types of industry. And you'll find, based on the industry type you work with or for, there are going to be different types and different even levels, if you will, of baseline considerations and compliance measurement considerations in order for organizations to pass compliance rules and audits and be able to get their business license renewed, on an annual basis. I also mentioned several times already the SCAPE the Security Content Automation Protocol, SCAPE. That is it's a guideline and a framework as well, and it includes references to several different markup languages, and most of those are derivatives of XML, tagging type of languages that allow us to share information among different disparate types of systems that may be spread out over thousands of miles from one another, but it allows us to tag and mark up the largely text information that we come from some of these databases like the Threat Intelligence Database and the Vulnerability Enumeration Database, the National Vulnerability Database. And there are several different languages that fall under that SCAPE umbrella and that protocol, as it were, that allow us to interconnect these very different systems that run on different hardware, different operating systems, under different software, but allow us to exchange information among those systems, much like an API, an application programming interface, so that those very different disparate systems can communicate in a like manner. Okay. There is a function of sort of a sublevel, a subcategory, as it were, of the SCAPE protocol that is specifically oriented towards assisting organization in passing compliance audits. There's the SCAPE Compliance Checker, SCC, they call that. And it is, you drill down into it, and there's search criteria there where you can look at compliance regulations or compliance requirements in different industries. And there are guidelines and framework information there on how to set up and make certain that an organization could indeed pass a compliance audit. And again, it's searchable. That whole database engine there is searchable based upon the type of industry that you work with or for there. So the OpenSCAPE there, that is an open source version of the Security Content Automation Protocol. It's the same kind of framework and guidelines that you have in the many of the for-fee commercial types of products. But really, it's an overall guidelines, standards, guidelines, procedures, framework, bits of information that many, many different organizations utilize to exchange information again among different and disparate types of systems. The components in a network environment that are utilized to actually move the data frames and the packets through a network. Switches and routers. Switches, of course, operate at a port level typically. They operate more often than not MAC address to MAC address, port to port communication ports. I've mentioned a couple of times already the implementation of these new managed multi-layer ports that are now beginning to take on the responsibilities and the roles of both switching and routing functionality. And those devices, I am certain, are being put in place in order to accommodate the next wave or the next version, as it were, of the internet, as well as the next version of the IP addressing scheme. I've mentioned you guys already. Currently, we are in the IP version 4 IP addressing scheme. It's a 32-bit binary address. And of course, we human critters see it as a numeric address, 192.168.5.15 or 10.10.1.32. It's got the 4 octets of numeric values, and each one of those 4 octets actually is directly related with 8 binary bits of that total 32-bit binary address. So that's how it is currently. Now, we are literally beginning to run out of available publicly assignable IP addresses in that scheme, because in that whole address range space, any of you network hacks are already familiar, there's only about 340 billion available addresses in that range. Well, they didn't think about, the fact that most households currently are, they need to accommodate somewhere in the neighborhood of 6, 8, 10, 12 different IP addresses for public IP addresses. And then, the rapid growth of companies, small, medium, and large companies all over the world. Well, the half of that address range is being allocated, or they call it leasing, private IP addresses to either private individuals, private companies. They're running out of them because they just didn't think about everybody having these multiple devices within their organization, certainly within the home. Okay. So now the new version, the IP version 6, is a 128-bit binary address, and we will be seeing it, of course, as a hexadecimal address from the IP perspective rather than a decimal address. And in that 128-bit footprint, that accommodates a total of, and I love this, a numeric term I never heard of before. It's called 300 undecillion. I'm not a mathematician. I did play one in a movie one time, but that's about as far as I got as far as mathematics. But in that range, it will accommodate some 300 trillion addresses. That's more IP addresses than we will ever use up in our wildest dreams on this and 4 or 5 other planets total. Okay. So that's right. Yeah, 10 to the 38th power. That's exactly right. You got it. So it's a vast addressing space. It is a vast amount of available addressability, and it's cut and dried. It's very simple if you look at it too. The whole subnetting concept goes away. The difference in private and public addressing goes away. The first 64 bits of the address is network address. The last 64 bits are individual appliance address. And embedded right inside of that last 64 bits is going to be the non-changeable MAC address, which is embedded into each NIC, the network adapter. Okay. So the switches and the routing functionality is sort of being merged into these new managed multi-layer devices now. And if you add on top of that, too, the ability for doing the virtual local area network definitions down under the covers in the switch, well, it truly just does away with a lot of the things we had to worry about or still have to worry about in the IPv4 world. Now, these new devices, not only are they taking on multiple roles, but they still must have the good, strong security mechanism wrapped around those things. You have to change the default credentials on these things. You know, these things come out of the gate with a default administrative level user ID and password. And those are published out on the World Wide Web. So you got to change those default credentials. You can, in any communication ports, physical ports on those devices that are not being used, either need to be disabled or deactivated or assigned. I always assign them to a placeholder virtual local area network definition rather than the default VLAN 1. So I'll create a higher order, a VLAN 999, and assign all of the unassigned ports to that. Therefore, if I need to then allocate some of those to some of the existing other VLANs that I've created, I just change the VLAN designation. I don't have to activate it and then change it. Okay. So that's a preference as far as managing those things myself. You always need to utilize the secured protocols rather than the clear text protocols like HTTP. That's a non-secure protocol. FTP, non-secure protocol. Telnet, throw it out the window. Use secure shell instead. Even your protocols in your internal network protocols like your DHCP, DNS, LDAP, Simple Network Management Protocol, the email protocols, SMTP, POP3, IMAP4. Use the secure versions of those. And now, you know, they're using either the secure sockets or the combination secure sockets and transport layer security that's implemented by these relatively new tunneling protocols, we call them. Have a requirement for a virtual private network client on every client machine. That is, you know, especially those that are dialing in from a remote location there. So, and all of your systems that are, you know, does some type of inbound, outbound package evaluation, excuse me, all of those systems should be set up to process that inbound, outbound scrutiny based on your access control list. Access control lists are made up of groupings of access control entries that define the rule sets or the filters that all data frames must process through in order to be accepted and or denied. Okay? And most of the devices still are operating in that whitelisting implicit deny mode. So a packet is introduced, it is, you know, you go down the script list, allow this or allow this or allow this or allow this, but deny everything else. So as I've said before, unless a rule is explicitly allowed, then the system implicitly denies it. I can also go an extra step on these devices, all of them. I can implement very strict port level security. And these devices now, just like your routers, the old router devices, even some of the old bridge appliances there, and now even in your wireless access points, those guys, I can set up filter list or accept or allow lists for processing based upon MAC addresses. And I can even set up on the managed multi-layer switches, excuse me, I can say, well, only the computer with this particular MAC address is allowed to connect through this port, period. So I do port level security, that 802.1, the extensible authentication protocol stuff. So there's several different layers and approaches that I can implement now with these new converged types of appliances that give me multiple wrappers of security around each and every session that I allow into my network, as well as the sessions that are flowing out of my network. I can do that same type of port level security and scrutiny and set up inside the switches, they call it a CAM table, a content access management table. And it processes the inverse of that, the MAC address, MAC rather than CAM. So I set up in there a listing, and every time somebody plugs in to a new port, I take that MAC address and put it in my CAM table. Okay. So if I've got a 24 port switch, then I'll have 24 available entries in my CAM table. that logs each and every MAC address that logs in, and it associates it with that port. And then I can even use the access control list to enforce, is it valid for this computer to hook up to this port? Yes or no? It's a simple thing. Okay. So that's how I do and set up these new converged devices. Used to, I had to split that up between a switch and a router, and they had very, very differing rules that I could implement there in order to set up the security around those things. Okay. I also need to set up and design in specific security baselines for individual systems. For server class machines, those typically run, either a Windows server like a domain controller or server operating system. Then I'll have the individual host machines that run usually, slightly different versions of the OS. In all of those systems as well, I need to harden the system, they call it, changing the default configurations. And always implement that principle of least privilege. A system need only have, or a user need only have, the minimum level of access and permissions required to perform the job function. And I approach that on the system configuration and the hardening as well. And you guys, I know you have seen it before. You buy a new computer, or you get a new phone or a new tablet, and boy, it comes loaded down with bloatware. It comes loaded down wide open from a configuration perspective. And I'll give you an excellent example there. My lovely wife is an iPhone user. Now, I keep trying to tell her to upgrade to an actual telephone that runs Android, but you might imagine how that goes. Well, when she got her latest iPhone, and this has been a couple of years ago now, and because she keeps bugging me now to get her a new one, but she gets the old iPhone. She comes to me, I don't know, a week after she got it. She's going, I plug this thing in every night. I charge the battery all night long. And then the next day, I only get a couple hours of use out of it. Then the battery's dead. So I said, let's take a peek. So we got in there, looked in the settings of the device. And there were 18 background processes that were being automatically loaded up every time she booted the machine up. 2 of them she used every now and then. Okay. And it was those background processes, servers, programs that I guess they were fired up just hoping maybe she'd use them. And if she did decide to use them, she didn't have to wait that 3-4 milliseconds until the application actually started up. So we went into the settings, shut all that stuff down. Well, not only did the other things, that apps that she ran and processes that she used tend to run faster, her battery now lasts a couple of days without on a full charge, And so folks don't really understand the battery on those mobile systems. That's the power plant. That's the strength of the system. If you have all these background processes running, not only does it eat up CPU time slice and main memory and network bandwidth, it also sucks the battery dry in a real short order. So after we shut all those down, now she starts getting good solid utilization out of a battery charge. And it works the same way on any mobile portable types of devices. Telephones, tablet, phablet, even a portable laptop type system. Also, when you take these systems out of the box, they fire up and they have installed on the system all of this bloatware. And they're trying to, to entice you into purchasing something. Yeah, we're going to run this McAfee system for 3 months for free. And then we're going to start throwing pop-ups about every time you do anything, trying to encourage you to buy it. Okay? Strip that bloatware, that crap out of there, and you'll get much better use of the system in general. Utilize things like the STIGS document, the standard, the security technology standards there to set up your security environment. Utilize the Center for Information Systems, that framework and recommendations information there. Make certain that you have, especially at server levels and especially configured into the hardware and the operating system level, the strongest controls that are available as part of the hardware appliance as part of the operating system that runs on it. And then any additional ones that you need to wrap around that, well, you need to put those in place as well. You need to be concerned about not only the technical and logical setup security of individual appliances, but also the physical security. We talked about that in the last lesson. Don't leave systems laying around on the desktop overnight. Lock it up in a desk drawer. If it's a computer system, lock it up in a vault or in a cage, a processing cage of some sort. Your server rooms, your server racks, lock them up. Everything in there is almost everything nowadays, anyway, is portable. Is very small footprint devices, very easy to steal. Any of the services, communication ports, physical ports, logical ports on a system, if they're not required for the function of the device, disable or deactivate those. And I'm talking about even things like USB ports on your laptop, HDMI ports, any physical port, as well as the logical ports, communication ports. If they're not required for the functionality of the appliance, disable those. Okay? And that's called hardening the device, by the way. And all of the devices nowadays, they come out of the box just wide open. And I'll give you an example too. You guys probably aware of this. There is a website out there, routerpasswords.com. Gotta love this. Every model and brand of router that is manufactured all across the world publishes their administrative level user ID and password on this website. Or they don't. There's the website proprietor here does. Let me just choose one. Let's see. We'll do. Let's see. Where is the? We'll do Asante. Okay, that's not a very well-known router, but I've used one of those before. So we fire it up. Well, there's the password, the user ID and password, and this is the administrator user ID and password for each one of these devices, switches, routers, okay? And it's published right there on the worldwide interweb. If the bad guys drive by your location and they happen to see one of those devices broadcasting a signal, all they got to do is check that website, find the administrator password, see if it has been changed or not by trying to log into that device's management console. If they gain access to that, keys to the kingdom. They got access to every system that's logged in through that thing, communicating with that thing, and all of the resources on all of those systems. So absolutely, when you're setting up these new devices and systems, principle of least privilege always should be implemented there. Now, the wireless world a little bit different. There is a tool. I'll give you guys a link to this as well. It's a great little tool. I run it on my Android tablet. It's called the Wi-Fi Analyzer, and it's from this company called CoolSoft. It is a free downloadable tool. Here's the link to that tool, by the way. I use it to basically do a walkabout in my wireless environment, and I can locate and identify all of the wireless signals, the SSIDs, that are being broadcast by any of the WAP, any of the wireless access points. Cool little app, runs on a phone, looks like this. Gives me information about individual signals, the strength in dBs of the signal, channels that it's broadcasting on, frequency that it's using, 2.4 gigahertz, 5 gigahertz. Shows me any overlapping SSIDs, again, what channels they're broadcasting on, the strength of the signaling, that kind of thing. And it just runs as an application right on my mobile phone or my tablet device. Now, currently, it is only available for Android appliances, but it's a great little device that will allow me to basically paint a heat map of my wireless environment in general. Okay, there's several of them. Here's another different. This is Lizard Systems Wi-Fi or wireless scanner here, a panel on that run like a Windows GUI interface. But I've got this CoolSoft Wi-Fi analyzer running on both my mobile phone and my Android tablet. And it gives me that ability to just do that complete site survey. I can paint a heat map of the site, figure out if I've got interference, from overlapping channels, things like that. Now, as far as setting up the devices to be secure in the wireless arena, based on the type of device, most of them come out of the box with the ability to set up one of three basic types of connectivity and security type of environment. Most of them come out of the box with what's called WEP, wired equivalent privacy. There are script programs you can get off the internet today that will crack that open in a matter of hours. I always recommend that people set up at a bare minimum the WPA version 2 enterprise mode. That's Wi-Fi protected access, by the way. It actually incorporates a very strict three-way handshake process. If you go up to the latest version, WPA version 3, it's actually a four-way handshake, much more secure. And if you go to the enterprise level of that, it also allows you the ability of setting up multi-factor authentication, as well as incorporating encryption algorithms, very strong encryption algorithms. And it incorporates a thing called SAE, simultaneous authentication of equals. The client machine authenticates to the server, the WAP, the wireless access point, and then the WAP authenticates back to the client. And it's a digital certificate concept and exchange of key structures. And it also negotiates real time at the session level what encryption algorithm is going to be used to encrypt the data. Okay? So very, very secure. Now, there is also all of these appliances include this clever little function. It's called Easy Connect or Universal Plug and Play. Officially, it's referred to as WPS, Wi-Fi Protected Setup. And it's a physical button on the outside of the box. And I understand why it was included, because when they first started releasing these Wi-Fi appliances, the general public was not terribly technically savvy. So they often had a difficult time just configuring, hooking up the Wi-Fi appliance so they could use it. So what WPS allows you to do is you go to all of your laptop, your phones, whatever appliances need to communicate wirelessly through the WAP, and you turn on their Wi-Fi signaling. You go then to the wireless access point, press this Easy Connect button, and it automatically reaches out and connects all of those Wi-Fi devices without them having to key any credentials in. It automatically connects those suckers. Well, that is a security issue. In my humble opinion, if I'm setting up wireless access points in an enterprise company type of environment, I'll disable that. And people are saying, well, you have to get physical access to the device. Yes, you do. And it is amazingly simple to get physical access to a device inside of an enterprise network. Amazingly simple. A bare minimum for me, I would say WPA version 3 Enterprise gives me the strongest encryption, encapsulation, and handshake connectivity that is available out there. And that's the SAE, the simultaneous authentication of equals. Both devices authenticate to one another. Okay? And disable the WPS there. If you set up the enterprise version of either the WPA2 or WPA3, it requires that you set up a AAA compliant services piece. Most of them come out of the gate with Radius installed, which is remote authentication dial-in user service. And there's another version, extensible authentication protocol, which gives me the ability of doing port level security and protocol access there as well. There's another one, I told you about it yesterday. There's another security function. It's called Diameter. It's not an acronym, but they claim that Diameter is twice as strong as Radius. I'm not absolutely sold on that. And Diameter, you don't hear a whole lot about except in large industrial control systems, things like that. But Radius, a remote authentication dial-in user service, is very strong encryption algorithms supported there. and it supports that four-way handshake too, that simultaneous authentication of equals, and it gives strong passphrases or passcodes, connectivity codes that are required for these things to connect to these WAP as well. All of those things together constitute what we call network access control. Setting up strong IAM functionality, the identity and access management functionality, setting up strong AAA compliant services. And remember, those three A's are authentication, authorization, and accounting functions. And that's baked right into most of these devices here as well. The network access control gives me the ability of configuring both authentication at the service level, the device level, and the user level. And all three of those levels must pass muster in order to gain access to a network connection of some sort. This screen you see here is called packet fence. It is it provides the ability, or supports rather, a couple of different scanning techniques. I mean, like I'm talking about authentication or vulnerability assessment scanners, Nessus, OpenVAS. Both of those are supported. There's a couple of other systems too that can be used to scan the devices by way of this packet fence. It's very similar to Wireshark in that it allows me to capture and analyze data frames and packets. A little bit different concept though, because of some of the additional components that packet fence will allow me to capture and to evaluate information. It will allow me to use the Windows WMI tool, the Windows management interconnectivity or interface instrumentation panel. It will allow me to process output queries from WMI, output queries from the PowerShell shell editor. So it stretches a little bit further than tools such as, or just standalone tools like OpenVAS or Nessus. And it will even process information that is generated from those open vulnerability assessment tools. Okay. So it allows me to set up filters and rules that dig a little bit deeper in the network authentication protocols than just those standalone packages would. And so it works quite nicely with either of those, as a matter of fact. Baselining the network security is something that I've talked a lot about, and I need to do that for all of my network access systems, both wired and wireless. And all of these collections of processes, protocols, and approaches really constitute the overall framework of what we call network access control, NAC. And it includes a lot of different outlying packages and approaches as far as the collection and the evaluation and analysis of the data, for sure. This lab exercise right here, again, one that if you've never done it, all right, Hector, I will email the homework. You be safe, sir, and thanks for the heads up. I appreciate it. So I guess Hector's already bailed here. I didn't catch that chat quick enough. This is a lab that, again, I think you'll enjoy doing it, but it is not really going to contribute much as far as answering questions on your exam, over and above what the lesson quiz in this lesson will do, and what your general study would do, and what we went over in the lecture as well. There are things that I can do to sort of beef up and enhance my base level network security. There are certain systems that I can deploy to do just that. Now, we've talked about your ACLs, your access control list. Access control list is a set of filters, rules that I define in things like my firewalls, my intrusion detection, intrusion prevention, antivirus, anti-malware systems, even proxy services, same thing. The firewall rules are basically different flavors and versions of access control lists. It's a top to bottom filter type of process. Now, most of your older legacy firewalls very, very limited in what they could actually investigate as far as the data frames. Your next generation, the newer updated firewalls are much more sophisticated. They act like more of a combination between a firewall and a data loss prevention system. They can investigate data frames and packets, the header of the packet, as well as the data payload. They can change the data payload. They can make much more sophisticated if then else kind of decisions rather than just the header kind of information. Is it from this IP address or this IP address or this range of IP addresses? Um, and if so, do this with it, that kind of thing. That's about the older legacy firewalls limit. Now, the newer ones are much more sophisticated than that. I can also set up, and I can do it by way of redirecting traffic if I wish, by processing, primary rules. I can set up and redirect traffic into like a DMZ, a neutral zone, a screen subnet, we call it. And they are screened and typically isolated between firewalls, an outward facing firewall, inward facing firewall. We talked about it as the DMZ. I can set up and only allow access into that screen subnet based upon very specific criteria. I can open up to the public, but they got to pass muster on the criteria I'm looking for, or they don't gain access into that screen subnet or that DMZ. That's where I was talking about the jump servers that we set up for the management systems inside the environment. IDS, IPS, we talked about those pretty good bit of detail already as well. IDS is more passive. IPS is much more active. IDS is those that can say, hey, we're being robbed. IPS is say, hey, we're being robbed, lock the door, pull out the gun, up against the wall, fool. It's more active as far as enforcing rules and taking action based upon an alert of some sort. Okay. Now, I think I gave you guys, I'll give it to you again anyway. It's one of my favorite utilities. It can be deployed actually as an IDS system or as a sort of like a firewall. I love their mascot too. Snort is the utility. Very simple, in my opinion, to set up and configure. It can be set up again as an IDS system or as a firewall. There's a couple of other open source systems out there that can perform the same kind of function. OSSEC is another of those, an open source, basically intrusion detection system. Suricata, I have not used myself. I have read lots of information about it, but it's not one that I have delved too far into. The Security Onion is one that I have used. That gives me its intrusion detection capability, but I can also utilize the Security Onion as some more active kind of things, like an intrusion prevention system as well. And it's open source. I mean, it's a full open source, very nice graphic user interface, very easy to configure and set up the filters and the rules there. So again, main thing to remember there, IDS is more passive. It can tell you, hey, we're being robbed. IPS is more active. Hey, we're being robbed. We're going to stop the intrusion right now, kind of thing. So a little bit difference there, and both of these utilize typically these things were started, and they were originally had predefined rule sets built into them, and they were signature based. They were dependent upon a small database, and they had signatures of anomalous type of behavior, and it was pattern recognition. Now there are those, or used to be, but they're sort of converged now in doing both signature, anomalous, and behavioral based making decisions there. And they do it because all of these mechanisms now have a machine learning interface baked into it. So it truly does learn over a period of time. First, what your particular profile and environment looks like, and then what recognizable patterns that it's looking for, anomalies in, like anomalies in the size of the traffic requirement, the type of traffic that's being introduced into the systems, and even now can be programmed to look at even user behaviors. In addition to all of these other data points that it processes and makes decisions based upon that. These things are very, very pseudo intelligent nowadays. You need to, as well, on these devices, jump in the sandbox with them and prime the pump, so to speak. These things can be set up to look at what your normal baselines are. And then they begin to learn and make decisions on what those primary baselines are over a period of time. And in not too much time frame, maybe these things come out of the box looking at, let's say, 30 different data points, and then make a decision upon 30 different filters or rules. Well, over a period of time, because of the machine learning interface, these things build decision blocks, we call them, and they chain those decision blocks together. So over a very short period of time, rather than looking at 30 decision points, they may be looking at 3,000 and then making much more informed, much more sophisticated decisions based upon all of the signature-based, behavioral-based, anomaly-based data points that these things are evaluating real time for each and every packet now, including variances in user behaviors. Okay. So very sophisticated, again, pseudo-intelligent, and they make very, very intelligent decisions. And it doesn't take them too long. If indeed you baseline them and set those things properly, it doesn't take them very long to start making some really fast, really intelligent decisions on allowing traffic to go through or denying that traffic to go through. Okay. Web filtering, a little bit different thing. We use web application firewalls. Web application firewalls are designed to basically evaluate HTTP traffic, your hypertext transport protocol traffic. Some of your web filtering systems are very sophisticated as well. They now can change content. They can set up rules that block inbound HTTP requests based on looking at the data that's included in the request. They can they have the ability of decrypting and encrypting real time traffic if they're using the HTTPS protocols, hypertext transport protocol secure. Usually the web filtering and the web application firewall systems are part of the overall web server code. Microsoft, of course, has their IIS, their Microsoft Internet Information Service. They call it IIS. I know the latest versions of the Red Hat Apache tool suite is doing the same thing. They have these very sophisticated web filtering, and it sort of incorporates into a singular package the same functions, as it were, if you had a web application firewall, an antivirus, anti-malware system, and a packet filtering system all formed into one, intrusion detection, intrusion prevention, data loss prevention, web application firewall, all thrown into one. And they're very sophisticated. And many of them also now are including the artificial intelligence, the machine learning type of interface that does indeed start to mimic, intelligent human decision making over a very short period of time. So web filtering is yet another form of filtering out traffic, same functions that firewalls and IDS, IPS systems have been doing all along. But it's sort of combined into a singular type of mechanism in the web application filters and web application firewalls, for sure. So that, in a nutshell, folks, is sort of an overview. And, I typically throw out a good bit more detail on each of those security type of functions as it relates more to the network level protocols and components that are used rather than the individual host machines and host accounts. Okay? All right, let's jump on over here and do a couple of quizzes. And then we're going to give you guys your afternoon break. I got one more lesson that I want to make certain that we go over this afternoon. Let's see. Number 9 is how many questions? 13 questions total there. And if I remember correctly, lesson 8 had 21 questions. So there's your lesson 9 quiz. You guys are doing quite well, as a matter of fact, on these lesson quizzes, especially second time around. Everybody's doing quite well on those. I want you to, after you finish 9, go back and repeat lesson number 8. 21 questions there, or 28 questions there. I forgot. That's a bunch of them. So I'm going to set your timer up now for 45 minutes. That should give you plenty of time there to do both of the quizzes.